Shrewd Manager Christianity's position. The Shroud's carbon dating anomalies look more like a clue to image formation than a mistake. In 1989, Harvard physicist T.J. Phillips suggested that because the Shroud's image looks scorch-like, the body may have released a brief burst of energy during image formation, light, heat, or possibly even neutrons. Such a burst could have added carbon-14 and subtracted years from its tested age, especially near the epicenter of the image. The radiocarbon labs observed this same phenomenon. To explore this idea, nuclear physicist Robert Rucker asked a basic question. If neutrons radiated from a body and interacted with the cloth, what would actually happen? Neutrons are like customers in a coffee shop. Starbucks can't predict what a specific customer will order, but it can model the behavior of millions. Rucker applied the same logic. Using a well-established Monte Carlo nuclear simulation program, he ran hundreds of simulations, tracking tens of millions of neutrons under realistic constraints, body geometry, tomb structure, and cloth properties. The result was not a single carbon date, but a range of dates, closely resembling what the radiocarbon tests measured. Rucker begins with a major assumption, that a human body can release neutrons. He openly acknowledges that no documented case of such a body exists, whether living or dead. So yes, this proposal begins with a big what if. But it's scientific because the assumption is explicit and the predictions can be tested. In our view, this idea shows promise for several reasons. First, the physics is modest, not extreme. To shift the Shroud's apparent age by about 1,300 years, only a minuscule fraction of the body's neutrons would need to be emitted, about 1.5 neutrons in 10 billion, and only a fraction of those absorbed by the cloth. Second, the hypothesis makes clear, testable predictions. Good science risks being wrong. Einstein's theory of gravity broke with Newton's, yet it survived because it predicted that gravity would bend starlight, later confirmed during an eclipse. In the same way, if neutrons altered the Shroud's carbon-14, different regions of the cloth should yield different dates, depending on distance between cloth and body and draping properties. Future sampling could test this directly. If the pattern isn't found, the idea fails. Third, Rucker's work fits within a broader line of research on Shroud image formation. Researchers such as Rinaudo, Fanti, Antonacci, and Di Lazzaro have independently argued that a short, intense burst of energy could explain the image's extreme superficiality and embedded three-dimensional information. Whether these ideas can be unified remains open, but they point in a similar direction. Fourth, Phillips' proposal and Rucker's work may help explain other puzzles. The Sudarium of Oviedo is traditionally identified as the face cloth mentioned in John 20, verse 7. Forensic studies indicate the Sudarium and the Shroud are consistent with having covered the same wounded body, based on matching blood flows, composition, locations, and dimensions. Yet unofficial tests place the Sudarium's radiocarbon date around 700 AD, roughly 600 years younger than the Shroud's blended date. That raises two questions. How could two cloths that wrapped the same body minutes apart age test to over half a millennium apart? And how could a cloth documented in Jerusalem before 614 AD test a century younger? Rucker proposed a simple explanation. John's Gospel says the face cloth was found separate from the body. If it had been placed on a bench away from the corpse, it would have received fewer neutrons. Fewer neutrons means less carbon-14, which means an older tested date. When Rucker placed a cloth in that position in his simulation, the predicted date closely matched the Sudarium's tested age. Fifth, ultraviolet photography adds converging evidence. Visible light shows the image as faint and fairly uniform. Under ultraviolet light, however, subtle variations emerge, strongest near the face and torso and fading outward. Researcher Thomas McAvoy interpreted this as a radiation-like pattern with directionality and fall-off. aligning closely with Rucker's predictions of the same uneven exposure. McAvoy also reports that neutron irradiation increases UV fluorescence in modern linen and raises its chlorine-36 content, showing that neutron exposure can leave both optical and nuclear signatures. He calls for new independent tests, including high-resolution UV mapping of the shroud, isotope analysis, and controlled irradiation experiments on linen. These would allow the hypothesis to be directly tested or falsified. Taken together, Phillips proposes the mechanism, Rucker models its consequences, and McAvoy provides experimental and imaging data consistent with those predictions, while leaving the question open. In sum, if neutron absorption played a role, the strange carbon dating results are not a problem. They're exactly what we should expect. Instead of averaging away the differences, this approach treats them as clues. Whether the hypothesis is correct remains unknown, but it offers a testable explanation that takes the full laboratory data seriously. Next, we'll look at attempts to unify neutron absorption with other proposed models of image formation.